the stability of carbocation, and there we have found, no, I have discussed about the inductive effect. Then I discussed about the resonance. Then I have told you that the stability of carbocation depends upon two factors. It depends upon inductive effect of the alkyl groups and the hyperconjugation effect. Okay. And the stability of the carbanion again depends upon the inductive effect. If the carbanion is having more alkyl group, in that case you have more repulsions, and due to more repulsion, the stability of the tertiary carbanion decreases. Is the least one. Methyl carbanion does not have any alkyl group, so it has least repulsion, so it is the most one. Then I have also told you whether it is the free radical carbocation or carbanion, benzyl free radical, benzyl carbocation, benzyl carbanion, we found in all these series, three series is most stable. And why it is so? It is because of the resonance effect. Okay, in case of benzyl, it is also due to hyperconjugation. So, in such case, let us see the stability of different groups because of hyperconjugation. This is essentially for your entrance exam. So those who do not want to appear entrance exam, you need not even write it. See, it does not have any methyl group, so no hyperconjugation. Achha, Gitanjali Pal is also there.
Yes, sir.
Hello, Gitanjali Pal.
Yes, sir.
नाम बोलली ना तখন
স্যার বলেছি
বলেছি তুমি শুনি নাই যে
বলেছিলাম
You are still in Bangalore.
Yes, sir.
See here, each hydrogen is going to show hyperconjugation effect. So 3 plus 3 plus 3, 9. Six. See, it has no methyl group, so no hyperconjugation. This is tertiary free radical. You write down here. Tertiary free radical. Mulika,
Yes, sir.
now what chapter is being taken in your school?
So this chapter only organic chemistry.
Who is doing? Mohua
Yes, sir.
and Kolita?
He's not there, out of station.
Achha. And methyl cation. Tertiary free radical, secondary free radical, primary free radical, methyl radical. Right. Everything I cannot write for you. What are the different types of reactions? You can see it in organic. This is not being given in your book. After finishing, don't remain quiet. Others simply I write and rub, write and rub. Then you'll have problem. Finished? Huh? Don't go for hibernation.
Yes, sir.
See the word substitute, you know, means replacement. You replace one by another. Say you want to go somewhere. Obviously, you do not go by wearing the dress that you are wearing at home. Okay? You change your dress and go. But you are the same person. Only the dresses are different. Okay? Example, say I have taken here you don't have to see anything here. This is the condition. See here, this hydrogen will be replaced by chlorine atom. From methane, you get chloromethane. Suppose I have taken here this, and I have taken here ammonia. This is a catalyst. See here, OH goes out, OH is a group. Okay, from there, NH2 enters. So one group is being replaced by another group. জল পিঠা গরম করেছেন Again, there are three categories are there. Anyway, this is not given in your book. If you feel that I'm giving you too much of information and it is difficult for you to understand, then you tell, then I will not give you so much. Okay. Before I go, I think I have to discuss now what is electrophile and nucleophile. Huh? That by mistake I did not discuss. Sometimes I also forget. All the notes that I have sent you till now, are you reading from mobile or you have? For this, let me know. Tell you what is called. Electrophile. Okay. Electrophile. This word has come from two words. What are those? Electron and philic. Okay. So what is electron stands for? It is a negatively charged species. And what is this? Philic means what? You all of you are from English medium school. What is philic? No idea.
No, sir.
Love or affinity. Okay. That is, it is a species which has affinity for negative charge. Okay, it likes negative charge. So what species will like negative charge? Guess.
Positive species.
Yes. Therefore, electrophiles are electron deficient species. The electron deficient, because of that they love it. Is it not? Suppose if your mother gives you more pocket money, you will happy or not? Or you tell your mother, no, I don't want so much money. What should I do? Do you say like that? Huh?
No, sir.
You feel happy, na?
Yes, sir.
Electron deficient species. Okay, now classification. Chemistry you can learn like this only. It is a part of our life. Okay, now see, there can be two types of poor human beings. You have seen poor people, na? We are all poor only. Is it not? So, there are two types of poor people. Can you tell me? Tell. We'll learn two examples. Chemistry. There are two types of. I'm telling you there are two types of poor people. Tell me. Say, I'm going to help you in thinking. No idea. What happened? Tell. See, those who are born in poor families, so they will be poor. Second, there may be some people who were extremely rich, but they could not manage their finance and wasted that money. And by that way, they become pauper. So similarly, we can classify these electrophiles in two categories. One who are born pauper. Okay, so we'll write here one. Neutral electrophiles. See, what is the concept of stability of a molecule? Concept of stability of a molecule is octet. So any molecule which is having incomplete octet, they are neutral, but they have not reached up to the octet level. They will always have a tendency to take electrons. And we have done those things in our hybridization. Okay? Okay? So what are those? Say I've taken here beryllium chloride. See, beryllium, each bond contains 2 electrons. Beryllium has 2 electrons, 2 bonds with chlorine, so 2 into 2, 4. So beryllium is incomplete octet. Out instead of 8, it is having 4. Okay? Then BF3, boron is having 6 electron. BCl3, 6 electron. AlCl3, 6 electron. Okay? These are all neutral electrophiles. Along with that, some molecule due to resonance, they develop electron deficiency because the electron, they are complete octet, but their electron is being taken by more electronegative oxygen. So carbon dioxide. All right. Carbon disulfide. Okay. Then sulfur dioxide, sulfur trioxide. These are all neutral electrophiles. Okay. Then second, I told you, no, they had electron, but they have misused it. They lost it. So these are called cationic electrophiles. Okay, like we can write here alkyl. It is the one of the hydrogen of the alkyl group is gone. So we can write here now here RCH2 plus. So all carbocations are electrophiles. Okay, now you can have say here Cl plus. I told you the name of Cl plus is called chloronium ion. Br plus, bromonium ion, NO2 plus, nitronium ion. These are all are cationic electrophiles. সামনে সোমবারে তুমি যদি যাই তো লিখতে পারো। শনিবারে তো আমি কালকে তো আমি যাইনি তো একটু 25 মিনিট হবে না। শনিবার দিন 12টাও দিব যদি চাই তো ভালো হয়। Done.
Done, sir.
Okay. Now we'll go for nucleophile. So it has come from two words. Nucleus. Now in a nucleus of an atom, what is found there? What is there in the nucleus of an atom? A moment I ask you any question, why do you go for meditation? What is there? Shagnik is there. Shagnik? Hello? What is there inside the nucleus?
The electrons and protons.
In the nucleus of atom also you have electrons. Who told you? Mallika, I think, na? Huh? Mallika, you have a separate type of atom or what? I knew that electrons remain outside the nucleus. For you, it is inside the nucleus also. Huh? সামনে মতে আইসি তোর মাথাটা আমি ফাটাই দিই। What do you have? Positive charge is there, protons. So, what should I write now? Thus, it is a species which has affinity for what? S.
Positive.
See, no, initially, please correct it. Initially, it should have been what? Thus, it is a species which has affinity for positive charge. Na? By mistake, I am written negative, we also written negative. Please correct in first definition. First division, you write this one. That is, it is a species which has affinity for positive charge. Please write. So now, for this one, I'm going to write it has affinity for negative charge. Therefore, nucleophiles are electron-rich species. So similarly here also, I can say that some people may be born rich and some people acquire wealth by their hard work. All right. So in that case, we can classify them as neutral nucleophiles. So what type of molecules will be neutral nucleophiles? those molecule has non-bonded electrons. Okay, the molecules which have non-bonded. What is meaning of non-bonded? Huh? Non-bonded. Non-bonded pair of electrons also has a name. We call them or lone pairs. Lone pair of electrons. Okay? Are neutral nucleophiles. মনে মতো কইলেন হ্যাঁ সমস্তটা বুঝলেন তো Okay, so let's see. I think I should take one test for you, Bulna. What do you suggest? Should I take? Najia?
I don't know, sir.
Right. What you don't know? See,
It's your call.
what you buy call, huh? Ammonia, lone pair. Phosphorus, lone pair. Water, oxygen has two lone pairs. H2S has two lone pairs. Alcohol, two lone pairs, etc. It is my call, na? Acha. ঠিক আছে. Then what about the opinion of others? I forgot also the name that you told me. Okay, let me see who else is there. It's a Somista is there. Somista? No, forgot. Malika, what is your opinion?
As you wish, sir.
Maria Thanda kore dimu. Sylvia? Are you there? Mahak, missing. Sneha, are you there?
Sir, your voice is cracking. I can't hear you.
Oh, I thought I'm telling you, should I take a test? Could you hear? Now you could hear.
Yes, sir.
Then I should. You are the only one who told me yes, sir. Very good. Kinsai, done ne? Kinsai? Acha. Then as anionic nucleophile. Okay, so anionic means they have become lost neutral atom and has become now negatively charged. See here, this is hydroxide, cyanide, chloride, bromide, iodide. Okay, then what? carbon ion, that is R CH2 minus, etc. So that I supposed to discuss before the types of reactions I should have done before I started, but anyway it is a mistake, but still we have covered it. Then again I'll go to this. So we'll go for now. Free radical. I told you this is not for your exam school. Huh? Free radical substitution. My question is that whatever we learn, we learn completely. Substitution reactions brought about by free radicals are called free radical. Okay, this example will do. When I'll go to, maybe after a few days, I'll start hydrocarbon. There you will find we have done it in this way. Substitution. See here. CH. This reaction I have already done just now. I have done it. I have taken Cl2 and ultraviolet light. So what happens? See here, dear. In presence of UV, it undergoes homolytic pH. So you get here now chlorine free radical. See. Now, chlorine free radical breaks this carbon hydrogen bond. You get now here methyl, and this hydrogen atom and this chlorine atom combined. You get this. Okay, then you'll find, see, there are two are there now. So one has removed hydrogen and the second one will come and combine. So what has happened in this case? See here. So what does it say? Substitution reactions brought about by free radicals. So chlorine free radical has substituted the hydrogen, and in that place another free radical has come. So this is an example of free radical substitution reactions. তাহলে তো কিছু জানাইল না, ফটো ফাটা নিয়ে এক সপ্তাহ ছিল। আরে কোথাও করে না, আমার তো মনেই করতে পারিনি। Now we'll go for electrophilic substitution. See, substitution reactions are like this. In electrophilic substitution reactions, what happens? One positively charged species replaces the another positively charged species. Actually, no, I should not put here. Initially, I put 1, 2, 3 like that. I'll put here A, B, C. Otherwise, there will be some confusion in numbering. The substitution reactions, which is initiated by electrophile, are called electrophilic substitution reaction. See, there are in our personal life also, we replace many things by two ways. One, by request. When that is when you request someone, when you are humble, means what? Huh? You do not have any control at that situation. You want it, but you do not have that power. So electrophiles are what? That electron deficient species. All right. So they go request someone, and this person is being taken inside, another person is being given out. Okay. So I'm writing like this here. See. This is we have taken benzene. Benzene, you know, everywhere you have hydrogen. And here you have taken chlorine. Let me write like this. I take a catalyst. See, in this case, what happens, you know? Cl plus come here, H plus goes out. So I'll write like this. Cl, and you get here H plus, and this Cl minus you get from here. So Cl plus remove the H plus. So it is an electrophilic substitution. Yes. Means what happens? In this case, FeCl3 reacts with Cl2. Okay, I'll write like this. Oh, everything I'm going to discuss if I get time. You get here FeCl4 minus and Cl plus. So this Cl plus comes here. And H plus from here goes out. You go for See here. Suppose I have taken here R maybe hydrogen or alkyl. Okay. Here I have taken X. So R is equal to alkyl or aryl means phenyl. And what is X? Say X is Cl, Br, or I. Okay. So this one, suppose I have taken here sodium hydroxide. See, this is ionic compound. What happens now? See, this comes and removes this. So what you get now here? You get here this and Na plus H and X minus. So this is hello alkane. And this is